Lessons over ratios. A ratio compares values. So a ratio says how much of one thing there is compared to another thing. For example, we have asterisks and we have the number symbol. If I would like to compare the two different values, what is the ratio of asterisk to number symbol that can be written in three ways? So we can compare these two values. So we can compare it as there are 3 asterisks to every 12 number symbol. We can write it with the colon symbol. There are 3 asterisk colon to 12 number symbols. Or we can write it as a fractional part. The ratio is another way to say fraction. There are 3 asterisk to 12 number symbol. As with fraction, ratios are often expressed in simplest form. Ratio can also be expressed as decimal. So we're going to be writing it in 3 forms, and then we're going to simplify it if possible, and then turning it into a decimal. For example, let's go back. As you can tell, there are 3 asterisk and 12 number symbols. We can simplify it. So if you simplify this 3/12, it's 1/4. How do you know? Patterson, they taught you that you divide. What number can you divide 3 and 12? What factor can be divided by 3? So it's 1/4. So, in other words, there are 1 asterisk for every 4 number symbol. Is that really true? Let's go back to our original picture. 1 asterisk for every 4 number symbol. 1 asterisk for every 4 number symbol. 1 asterisk for every 4 number symbol. So the ratio of asterisk to number symbol is 1:4, simplified, or 1:4, or 1/4, and the decimal part of 1/4. Get 4 going 1, 0 times. Get rid of the decimal, the remainder. We don't have remainders here in middle school. Goes to 2 times. So it's 25 hundredths. So the main thing, there are 25 hundredths times as many asterisks as to number symbol. That's the multiplicative comparison. Or we could say it backward. There are 4 times number symbols to every asterisk. So let's try this one. Can you find a ratio of dogs to cats? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 dogs to every 3 cats. Another way to write is 9:3 or 9/3. Multiplicative comparison. Is there another way to rewrite 9 to 3? 9:3 or 9/3. I break it down by 3 is 3/1. There are 3/1 or 3 times as many dogs as cats. Is that really true? Are there 3 dogs for every cat? Yep. Yep. And yep. So there are 3 dogs to every cat, or 3 times as many dogs as cats. Let's do another one. The ratio of cats to dogs. So this time they want you to compare the values of the cats to the dogs. So cats, there are 3 cats to 9 dogs. 3:9 or 3/9, which simplified to 1/3. So there are 1 multiplicative comparison. There are 1/3, or do you know the decimal equivalency of 1/3? It's a repeating decimal. In case you don't know, do 1 divided by 3. It goes in 3 times. Goes in 3 times. Look at it repeating. So it's 3,300 repeating. There are 1/3 or 0.33 repeating times as many cats as dogs. So let's try another example. The number of girls to boys is what? Girls to boys. Compare the two values. There are 3 girls to 2 boys. 3:2 and 3 halves. So multiplicative comparison. There are 3 halves, or what is another way to write this as a decimal? This is rewritten as 3 divided 2. There are 1.5 times as many girls as boys. Let's see if that's true. Here's a boy. If I take 1.5 girls, there's 1.5 girls to every boy. 1.5 girls to every boy. The ratio of boys to total now. This is boys total. So we're doing part to part now. It's part to whole. Boys to total is 5. Boys to total. 2:5 and 2/5. So there are 2/5, or what is the decimal equivalency of this? 0.4 times as many, 4/10 times as many boys as total. So does order really matter with ratio? It does, big time. Because if you don't pay attention, you could be writing the answer backward. For example, there are 3 girls to every 2 boys. If I did 2 to 3, that's saying that there's 2 boys to 3 girls. So order does matter. So we're going to skip this one. And let's go to this one. Mrs. Peacock placed some counters on her desk as shown. So we have all these different counters. Use Miss Peacock collection of counters to decide if each statement shown below is true or false. Justify your response with fractions, pictures, or words. The number of red counter is double the number of yellow counter. Is that really true? The number of red counter is double the number of yellow counters? No, it's not. There's triple the number of red counters. The number of red counters is double the number. False! That is not true. False. Justify. I would recopy this picture there. As you can tell, there are 3 times as many red to yellow. The number of yellow counter is 1/4 of the set. The number of yellow counters, to the set. So how many yellows do you see? There's 2 yellows. In a set, there are 1, 2, 3, 4, 5, 8. Can I simplify that? It's 1/4. That is true. There are 1 yellow to every 4 objects. 1 yellow to every 4 objects. That is true. The number of yellow counter is 1/3 the number of red counters. So the number of yellow counters, is 1/3 the number of red counters. Well, you can tell it right here from the picture. There's 1 yellow for every 3 red. So that's true again. And there are 2 yellows to 6 red, which simplify to 1/3. The total number of counter is 4/3 the number of yellow. So the total number of counters. So the total number of counters you see is 8. To the number of yellow, there are 2. That can be broken down by 2. It's 4/1. They said 4/3. That is false. It's 4/1. The number of counter is 4/3 the number of red counters. So the number of there are 8 of them in total, and the red counters are 6. I can simplify that to 4/3. That is true. It is 4/3. Because you started with 8 total, you have 6 red, and it's broken down by 2, and it comes 4/3. And last but not least, the number of red counters is 3/4 of the set. The number of red counters, 1, 2, 3, 4, 5, 6, to the number of sets. There's 8. Break it down, simplify, 3/4. That is true again. So, next item. Grab a handful of rainbow cubes. We're still going to use our yellow-red item. 10 out of every 14 students, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 out of every 14 students, 1, 2, 3, 4, take the school bus. So 10 people take the school bus, 4 do not take. Which ratio accurately compares the number of students who take the bus, 10, to the number of students who do not take the bus, 4. So does order matter? It does. because it will change the whole problem. Can you simplify this? Yes, you can. 5. So there are 5 halves. Or what is the decimal equivalency of 5 halves, or 5 divided by 2? Let's see, 2 times. Okay, 10, 2 going 10, it goes in 5. There are 2.5 times as many students who take the bus to the students who do not take the bus. Is that really 2? Here's 2. If I cut this in half, there's 1 person that takes a bus. So 2.5, no, don't take the bus. 2.5, don't take the bus. 2.5, don't take the bus. So it's true. Next one. 10 out of every 14 students take the bus. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 4 do not take the bus. Which ratio accurately compares the number of students who do not take the bus, 4, to the total number of students who do take the bus, 10. You can simplify that as 2/5. Do you know the decimal equivalency, the multiplicative comparison of it? It is 0.4 times as many students who do not take the bus as students who do take the bus. Mr. Logan has 24 students in class. 14 of the students take the bus. The rest of the students do not take the bus. Which ratio accurately compares the number of students who take the bus, wasn't that 14, who do not take the bus? So if there's 24 students, 14 take the bus, 10 of them do not. You can simplify that to 7/5. Do you know the multiplicative comparison? 7 divided by 5, 7/5 goes in 1 time. It's 1.4 times as many students who take the bus to those who do not. And Mr. Robert has 21 students in class. 6 of them take the bus. The rest of them do not. So 6 take. That means 15 do not. I could use my counters, but I'm not for this one. Which ratio accurately compares the number of students who do not take the bus, 15, to the total number of students, 21. Can you simplify this? Yes, you can. Divide both numbers by 3. You got 5/7. And what is the multiplicative comparison? 5 divided by 7. 5 by 7. Okay, 7 going to 50. It goes in 7 times. 1. I'm going to get rid of the remainder. Okay, 7 goes to 10. 1 time. And I'm going to tell you this keeps going forever and ever. But it's not going to be repeating 7, 1. It's going to be 7, 1, 4. I don't know what it is actually. If you really want to know, it's 3. It's 7.71452 something. So I'm going to estimate it as 0.71. So again, what is ratio? Ratio is a comparison of 2 values, 2 quantities. Does order matter when you talk about ratio? Yes, it does. So read the question up carefully. So it's going to say, they want you to find the ratio of this to this. So the first thing you see, you need to write it as either 2, colon, or a fraction, and then you can simplify and write it as a decimal ratio.